Okay guys, Timmy coming at you again today. And today what I'm going to do is I'm going to talk to you about shock. Now, what I'm really going to talk to you about today is the different stages of shock. And these are important because the earlier you recognize an individual is in shock or going into shock, the better the likelihood that they're going to survive. In another video, I will explain to you the different types of shock and how to treat it. But in this video, I'm going to explain to you the stages of shock. First of all, a couple of things, right? Number one. If you look at the cardiovascular system's primary function is to bring oxygen and nutrients down to the cells of the body. And one of the most important is oxygen. And oxygen is required to make ATP, the thing that our body runs on, the energy our body runs on, to make ATP aerobically. And that's the best way to make ATP. You can make the most, and it's the most efficient. So the definition of shock is the inability of the cardiovascular system to send enough oxygen to the vital organs of the body to maintain life. And if you recall, the left ventricle is responsible for sending oxygenated blood down to the cells of the body. And I hate to do this to you, but again, it's really important. The only place that nutrients and gases are exchanged in the body is at the level of the capillary in the cell. So what you're going to see a lot of is you're going to see two curved lines in a circle, hence my Facebook page, where you're looking at the cell, what's going on in the cell, and then you have the capillary. And if you recall from AMP, you have an arterial end of the capillary and a venous end of the capillary. And the arterial end of the capillary contains oxygen. And oxygen will diffuse from the capillary into the cell so that you can make ATP aerobically. So anything that causes the cardiovascular system's ability to deliver oxygen down to the cells of the body to make ATP aerobically is going to have a profound effect on the body. And again, the most important parts of the body to maintain blood flow to are, of course, your brain and your vital organs. So the body will sacrifice non-essential parts of your body in order to maintain blood flow to your brain and vital organs. So it will sacrifice blood flow to the extremities and to the skin in order to maintain blood flow to your brain and vital organs. So let's get into it a little bit. So let's look at this. I'm not going to read this to you because you can read, right? The definition of shock is the cardiovascular system cannot maintain blood flow to your brain and vital organs. So look, it's also defined as a mean arterial blood pressure of less than 60. That's a perfusion pressure necessary to maintain oxygenated blood to your brain and vital organs. It's called MAP. And it's determined by 2 times your diastolic plus your systolic divided by 3. So let me give you an example. Somebody comes into your emergency room and they have a blood pressure of 70/30. Yeah? Let's see if they're in shock. So it is 2 times the diastolic, which is 30, plus your systolic, which is 70, divided by 3. So 60 plus 70 is 130, divided by 3. That's a little over 40. So like 43. millimeters of mercury. That is their MAP. So by definition, this person with a MAP of less than 60 is in shock. What's causing the shock? I'll talk about that later. But you know they're in shock. And there are stages to shock. First of all, if the cardiovascular system cannot maintain blood flow and therefore oxygen to your body parts, this is what happens. And you remember this from AMP, that oxygen is gotten from the arterial end of the capillary, right? And it will diffuse from the blood and it will go into the Krebs cycle, electron transport chain, and you'll make ATP aerobically. You also have a way of making ATP that doesn't require oxygen. And this is enzymatically taking glucose and breaking it down to pyruvate. And normally pyruvate, when there's oxygen around, diffuses into the mitochondria and you Krebs that thing out, so you completely break down the glucose. But in the case where you're not delivering enough oxygen down to the cells of the body, glucose to pyruvate predominates. Ain't that great? Don't hate, educate. So because the cardiovascular system is having problems for whatever reason, who cares about that right now, there's going to be decreased oxygen down to the cells. So basically what's going to happen is aerobic metabolism is going to slow down, or as the shock worsens, it's going to stop. Your cells don't care. They need ATP to make those things, to make your cells work. So your cells have the ability to take glucose, break it down to the stuff called pyruvate, and make ATP without oxygen. That's a good thing. The problem is that if the pyruvate can't go into the Krebs cycle because there's no oxygen, and why isn't there any oxygen? Well, your cardiovascular system is having problems, right? You're in shock or going into shock. So glucose to pyruvate is going to predominate. Ain't that great? And it's going to make ATP without oxygen. The problem is pyruvate can't go into the Krebs cycle because you ain't got no oxygen or very little. So the body does stuff that makes sense. It takes pyruvate, which is a pretty strong acid, and breaks it down into lactate or lactic acid, which is a little weaker. Plus, lactic acid is permeable to the cell's membrane and can diffuse into the blood. But what are you dumping into the blood? You're dumping acid into the blood. And when you dump acid into the blood, that drops your pH. You develop an acidosis. In this case, you develop what's called a metabolic acidosis. Metabolism is producing acid, metabolic acidosis. And this is important, this is critical. Enzymes and pH. Enzymes control the metabolic pathway. So they break down glucose and fat to make ATP. The important thing to remember is that enzymes are temperature and pH sensitive. They work best at a pH between 7.35 to 7.45. But if your pH is dropping because you ain't got oxygen and you're taking glucose to pyruvate and making lactate, lactic acid, and dumping into the blood, you're going to be dumping acid into the blood, and that's going to lower the pH. And when you lower the pH, the enzymes of metabolism don't work so good. And as that pH begins to drop, if you don't do something to improve the amount of oxygen down to the cells of the body, metabolism won't work, no ATP, and you dead. So what initially happens in the initial stages of shock is there's going to be some condition that's going to cause the cardiovascular system not to be able to deliver enough oxygen down to the cells of the body, right? Brain, vital organs. The result is that anaerobic metabolism, making ATP without oxygen, is going to take over. And what's going to happen is you're going to start taking pyruvate and converting it into lactate and dumping it into the blood. And that's going to drop your pH. So that's the initial stages of shock. Then you go into the second stage of shock. The second stage of shock is the compensatory phase. Now this is important. As blood or as oxygen begins to decrease and you start dropping your pH and there's lack of oxygen to the brain, anytime you lack oxygen to your brain and vital organs, that is going to stimulate a division of the autonomic nervous system called the sympathetic nervous system. And the sympathetic nervous system is the fight or flight portion of the autonomic nervous system. Its purpose is to prepare your body to run or fight. You're in trouble. There's stress on your body. You're going into shock, right? You want to prevent that from happening, so you want to make sure that your brain and vital organs are getting enough oxygenated blood. So you activate the sympathetic nervous system, and the sympathetic nervous system also innervates the adrenal medulla. And the adrenal medulla releases our buddy, our pal. Let's hear it for the one and only. Whoops. Come on, let's hear it for the one and only. Well, that's... Wait. Forget it. I'll try that. Oh, yeah, I know. It's new. I'm struggling. Trying my best. The sympathetic nervous system is going to innervate the adrenal medulla, the inner portion of the adrenal gland, to release the hormone epinephrine. And epinephrine, as you recall, is a hormone, and it binds to beta receptors. So think about when you're scared, right? You got to take a test in my class. You're going to get the sympathetic nervous system stimulated, and it's going to produce wholesale changes in your body that are designed to prepare your body to run or fight, or in this case, there's stress, to prepare your body to maintain blood flow to your brain and vital organs. So one of the things I like to point out about the sympathetic nervous system is that when it's activated, all the nerves, the spinal nerves that come off the spine, then are connected together. So what that allows is massive wholesale changes in your body's physiology to try to maintain that blood flow to your brain and vital organs. So what's going to happen when these people are going into shock and the sympathetic nervous system kicks in? Well, how are you going to feel when your sympathetic nervous system kicks in? You're going to feel anxious, jittery, right? Your heart rate and blood pressure are going to go up. Your pupils are going to dilate. You're going to start breathing faster, right, and deeper. And one of the reasons you're breathing faster and deeper, right, is you're making acid at the cell. And the lungs have to help out with that pH. So what the lungs are going to do, and write this down, never forget it, tattoo it someplace. CO2 is an acid, right? So if the cells are making acid through the formation of lactic acid, in order to try to maintain that pH, in order to compensate for the acid that's being made at the cells, the respiratory system has to compensate. So if you're making acid at the cells, you got to get rid of it at the lungs. So what's going to happen is the respiratory rate is going to go up. So these people are going to increase their respiratory rate, how fast they breathe, and they're going to increase the depth of respiration. So they're going to be breathing faster and deeper, trying to get that CO2 out of the blood, because you're making acid at the cell. So the lungs, which control CO2, they're going to try to get rid of it. So that's one of the ways that they compensate. The heart rate and blood pressure are going to go up, right? So the heart rate is going to go up, the blood pressure is going to go up because of the effects of sympathetic nervous system and epinephrine. And when you increase your heart rate and you increase the force of contraction of the heart, how hard the heart contracts because of epinephrine and sympathetic, that increase in force of contraction is going to try to increase systolic blood pressure. That's what you want, because you want to try to deliver more oxygen to the cells of the body. Now, again, you got to maintain blood flow to your vital organs, right? So can you live without your arms or legs? Of course. So what the sympathetic nervous system is going to do, it's going to take the arteries that supply your arms and your legs and your skin, and it's going to cause those arteries to massively constrict. You want that because you don't want blood flow going to your arms and legs, because you can live without your arms and legs. So what's going to happen if you decrease blood flow to your skin and extremities? Your skin is going to become pale, cold, because you're not sending warm arterial blood there, right? You're going to be sweaty from the effects of epinephrine, so they're going to be cold and clammy. And as this progresses, they're going to become cyanotic. They're going to become blue because you're not delivering oxygenated blood to it. So the compensatory phase is trying to get your cardiovascular system in a situation where it is able to deliver enough blood to your brain and vital organs. Now, look, now watch for a second. Watch. And I'm not the greatest drawer. People know this. But you got these little things called your kidneys. And as blood flow drops, do you want to be peeing out your blood volume if your blood pressure is and blood flow to your brain and vital organs is low? So a drop in blood pressure to the kidneys, right? That's going to activate the renin, angiotensin, aldosterone system. Lack of blood flow to the kidneys turns that on. And the renin, angiotensin, aldosterone system does really basically two things. It takes arteries throughout your body that were like this, and it will constrict them. So it causes massive arterial vasoconstriction. And in the kidneys, it's going to cause the kidneys to reabsorb sodium. And if you reabsorb sodium, water will follow by osmosis. So the renin, angiotensin, aldosterone mechanism is another compensatory mechanism. The activation of the sympathetic nervous system, that's going to kick in. So if you reabsorb sodium in the nephron and the water follows, and blood flow to the kidney is dropping, urine output is going to drop as well. So what are you going to see in this patient during the compensatory phases? You are going to see them become anxious, the activation of the sympathetic nervous system. As blood flow decreases to their brain, they may become confused and agitated. Their skin will become pale, cold, clammy, as blood is diverted away from the non-essential parts to your brain and vital organs. That drop in blood flow to the kidney is going to activate the renin, angiotensin, aldosterone mechanism, and urine output is going to begin to drop. Now, if this isn't corrected during the compensatory phase, then it progresses. And you're not going to believe this, but you'll never guess what the next phase of shock is. And you got it. It's the progressive phase or progressive stage. So this person is lacking blood flow. The compensatory mechanisms are beginning to fail. That lack of blood flow to the brain is going to cause them to become unconscious. The breathing begins to slow and become irregular. And the reason for that is that as that acidosis worsens, the nervous system cannot perform as well. The sympathetic nervous system begins to basically shut down. So not only are you making acid at the cells through the lactic acid, but you're also now not able to get rid of CO2. So you're going to develop a respiratory and metabolic acidosis, which is going to make things even worse. And you need to know this. With the dropping pH, cellular enzymes begin to drop, right? They don't work as well. They fall apart. And if your cells can't make ATP because your enzymes are jacked up, this is what happens. Acidosis leads to hyperkalemia. Acidosis and hyperkalemia cause massive arterial vasodilation. And you know that high levels of potassium will decrease your heart rate and the force of contraction of your heart. So now your heart rate slows, your blood pressure drops even more because of the dilation, and now you can send less oxygen to the cells of the body. So you produce a little ATP. Muscles need ATP to contract, right? Diaphragm's a muscle, so your breathing begins to slow, no breathing, and then our buddy, our pal, the sodium-potassium pump don't work. And when you get to this point, you are now in the it's over for you phase. It's the, what is that called again? The last phase. I forgot, and you're going to have to look it up. This phase really has to do with our buddy, our pal, the sodium-potassium pump. And this is, in fact, how we all die, ultimately. Now, if you remember from anatomy and physiology, you got the capillary, you got the cell. In this case, this is how we really die. So we'll call this a brain cell, right? The brain cells are the most sensitive to changes in pH and in fluid shifts because the brain is encased in the skull, and the central nervous system, brain, and spinal cord do not have a lymphatic system. So any fluid shifts cause devastating effects in the brain and spinal cord. So watch. As the shock progresses to the irreversible stage, that's the last stage of shock, sodium from the blood leaks into the cell. Potassium from the cell leaks into the blood through these ion leak channels. And normally what happens is the sodium-potassium pump takes 3 sodiums that leaked in and pumps them back into the blood, and 2 potassiums that leaked out and pumps them back into the cell. Because you're going against the current, you're going against the concentration gradient, that requires ATP. Well, if you don't have oxygen, your enzymes of metabolism are jacked up because your pH is dropping, you're not going to be able to make ATP. So the sodium-potassium pump in your brain cells is going to stop. Sodium will begin to leak in. Potassium will begin to leak out. But when the sodium leaks in, water follows the sodium by osmosis. Boom. And because you're not getting it pumped out by the sodium-potassium pump, the water will follow, and you will pump up the volume of your brain cells until they rupture and you have permanent Dane-Bramage. That is irreversible shock. Now here's the thing, and you work in an ER or an ICU, and people don't understand this. Because the brain is the most sensitive to changes in pH and fluid shifts, a person with permanent brain damage as a result of this, you may be able to get their heart started and they may be breathing on their own. All of their other organs are working okay, but nobody is home because the brain cells have ruptured due to this inability to keep the sodium potassium in balance. So people don't understand this, and I'm hoping you do now, is that the most sensitive part of your brain to drops in pH and fluid shifts, or the most sensitive part of your body, is your brain. So they can have their other organs working, but as people would say, the lights are on, but nobody's home. So those are the stages of shock. I hoped it helped, and good luck.